Okay, so we're looking at calculating the number of daylight hours using the illustration that we've got here. Now, notice, guys, the solid line, this solid line represents what? The axis of rotation. Very good. This dashed line is the terminator. Tell me again what the terminator is. It's the boundary line between day and night. So do you see that this is daytime over here? This is nighttime over here. Got it? Okay. All right.
So shaded is night.
Shaded is night, yes. Sunlight's coming in from the left. Okay, so we've got the daytime side and the nighttime side. Now, here's the way we're going to determine just how many daylight hours we can expect at these latitudes. Okay, for instance, I'm going to look up here at my equator. That measures 9 centimeters. Okay? So, at my equator, 9 centimeters. 9 centimeters is going to represent my entire 24-hour day. Okay? And now I want to just look at what's my daytime part. My daytime part is over here. From here to the terminator, not to the axis, although for this one it's in the same location. That's at 4.5. Do y'all see that? You'll see that 4.5 marks where the terminator hits it. Okay. All right, you do bat and ball.
Wait, do we use calculators?
We're doing this together, so just, okay. 4.5 times 24 equals, divided by 9 equals, what do you get? Oh, Lord. 12, guys.
12.
Okay, so how many hours of day are we having at the equator?
12 hours.
12 hours of day. How would we get the number of nighttime hours for the equator?
Same thing.
It is going to be the same thing. What we would do is we would say 24 hours minus the 12 that we got, which in this case is 12 hours of night. Got it?
I get this now. Now you gotta go back.
Okay. Now we are going to do the next latitude, which is 25 degrees. Let's see. All right. I get a measurement of 8.4. So 8.4 in this case is going to represent my 24 hours. Where am I measuring to? I'm measuring to the terminator. Okay. So that's going to be, it looks like 4.8. I'm not measuring to the axis. I'm measuring to the terminator. Do y'all see that? So here to here.
Wait, so where to where?
I'm measuring this portion right here, the day portion on the 25 degrees. Okay, guys, you should see already that at 25 degrees, that the day is going to be more than the night, right?
Yes.
Because a bigger portion of that latitude is on the daytime side of the terminator. Okay, but again, you do your cross multiplication. We're going to say 24 times 4.8, divide that by 8.4. And you get 13.7 hours of day. How would I get my nighttime? Yeah, I'm going to do 24 minus 13.7. And that is 10.3 hours of night.
May you repeat what we're talking about the daytime?
10.3 hours of night. Okay. Down here on the 25 degrees south, what do y'all think it's going to do?
It's gonna be like really.
How many hours are a day?
Okay, if I have 13 hours quiet, if I have 13.7 hours of day and 10.3 hours of night up here at 25 degrees north latitude, at 25 degrees south latitude, it's going to be what? Exactly the opposite. So I don't even have to do a calculation down here. I know that this one's going to be 10.3 hours of day. And how much night are we going to have down here at this latitude?
13.7.
13.7 hours of night.
How many hours? 15.7?
13.7. Okay, so next we do our calculation for 55 degrees. I take my ruler and I get 6 centimeters. So down here for 55 degrees, 6 centimeters represents 24 hours. Okay, let's see. And looks like 4.3, 4.2, 4.2 of those centimeters is in the daytime side. So do your cross multiplication. So we say 4.2 times 24, divide by 6, and you get a 16.8 hour day. 16.8 hour day. Which means how much nighttime?
7.2.
24 minus 16.8, which is 7.2 hours of night.
You get no sleep.
Yes, the sun is going to be setting very late.
Wait, can you repeat the top row again?
You need to come up here if you can't see. All right. What about down here, 55 degrees south? What's the deal, guys? It's just the opposite. So how much day? 7.2 hours of day and 16.8 hours of night. Okay. Okay. In this particular situation, which hemisphere is having summertime?
North.
Yeah, this is the northern hemisphere's summer.
Miss Goff is coming.
Ah, leave. Okay. Northern hemisphere, summertime. Okay, which means obviously that it's wintertime in the southern hemisphere. You guys got that?
You got it, Miss Goff?
All right. Okay. What would you expect here?
They're all opposite.
They're pretty much all opposite of what you had up at the top. Okay, so now this is the northern hemisphere in the what? Yes, this is winter in the northern hemisphere. Shh. Okay. And remember, in the northern hemisphere during the wintertime, we're going to have short days and long nights. So what do you guys expect for 55 degrees north? I mean, we could do it and make sure the measurements were exact, or we can just assume that this is tilted back the same that this was tilted forward. So we're going to have 7.2 hour day and 16.8 hour night at that 55 degree mark. What would we have at 25 degrees north? 10.3 hour day and 13.7 hours of night. At the equator, 12 and 12. It's pretty much, guys, if you live at the equator, your days are pretty much 12 and 12 all year long. Okay, down here at 25 degrees south latitude. Yep, 13.7 hour day.
Jacob Carwell to the office of these things.
Yep. And a 10.3 hour night. Does that make sense?
Makes pretty good sense.
And then 55 degrees, you'd have a 16.8 hour day and a 7.2 hour night. Do y'all see how that works? Okay, so do you see what I did, just setting up a ratio using the latitude lines of how much was exposed on the daytime and nighttime side?
Yes.
Okay, real quickly, the back should be easy. We're at an equinox. What does everybody have at an equinox? 12 and 12 and 12 and 12. Everybody has 12. Pretty much everybody. 12, 12, 12, 12. Yeah, because if you look at each latitude line, you have the same amount of that latitude line on the daytime side as you do on the nighttime side. So everybody is experiencing a 12-hour day at the equinox.